If you are spending your days grounding through a calculus textbook to learn machine learning, you are following advice from 2019. That path of endless manual derivation is a dead end for what actually gets you hired today in 2026. The math you actually need to operate as an engineer is specific and bounded. You need linear algebra to understand matrix multiplication, enough probability and statistics to make sense of Bayes' theorem, and calculus up to the chain rule for backpropagation. Instead of solving equations by hand, you should build a geometric map in your head of what those concepts look like. Watch resources that animate the math so you can see a matrix transformation in real time, and strictly limit this phase to 4 weeks maximum. Skipping the textbook grind stops you from burning out early. It preserves your cognitive bandwidth for the coding and system architecture you will be executing constantly on the job. Once that math feels approachable, shift immediately to code. Python is the absolute baseline, along with libraries like NumPy for matrix operations and pandas for manipulating tabular data. This diagram shows the workflow trap most beginners fall into. You load some data, call fit on a scikit-learn model, and get a result. This creates the black box illusion. You feel like you understand the process, but if a model struggles in production, you are entirely guessing as to why. Dismantle that black box by writing out the math for an algorithm like logistic regression from scratch. You translate those exact equations into direct array operations using NumPy. This forces you to track exactly how data flows and changes shape through each matrix operation. Stripping away the pre-packaged abstractions turns theoretical equations into tangible logic. It also perfectly prepares you for modern ML coding interviews, which frequently ask candidates to implement these exact algorithms from memory. Let's test that foundation right now. If you were tasked with building a customer churn prediction model, pause the video and quickly name 3 core Python libraries you would use and the type of algorithm required. You would need pandas, NumPy, and scikit-learn to build a classification model. But in 2026, classical machine learning is only half the job. You also have to navigate generative AI, meaning you need to know how to build retrieval-augmented generation pipelines and how to evaluate if those systems are actually working. This brings up a major trap, the fluency illusion. Machine learning engineers use AI coding assistants constantly, and it is very easy to let the AI hand you perfect code, nod along, and trick yourself into thinking you understand it. This chart shows how your cognitive retention flatlines when you outsource your thinking. To actually learn, you must change your prompt. Use AI to explain a matrix operation or quiz you on a concept, but never let it write the final logic for you. Treating an AI assistant as an interactive tutor forces you to do the cognitive heavy lifting. That is how you build the resilient, original problem-solving skills required for complex engineering. Even with those skills, sending a resume filled with basic Kaggle notebooks to a hiring manager is a fast track to the rejection pile. Those datasets are perfectly clean, and the problem is completely laid out for you. To prove you can do the job, you have to build professional-level tools. That means finding messy, unique data and making your own architectural decisions from scratch. A real production pipeline starts by ingesting messy raw data, cleaning it programmatically, and feeding it into a Python model you built. Then you wrap that model in a Docker container and deploy it live to AWS, complete with automated testing and performance tracking. A deployed pipeline with continuous integration shows a hiring manager exactly what they need to see. It proves you are a capable, low-risk production engineer ready to handle real infrastructure. The path into this field is faster today, but it demands a completely different approach. We are trading manual math derivations for visual intuition, opaque libraries for raw code, and passive reading for AI-assisted active learning. Screenshot this roadmap. Build your visual math foundation, code algorithms from scratch in NumPy, master GenAI evaluation pipelines, and deploy a cloud project. Getting hired in machine learning requires you to look past the syntax. You have to prove you can systematically command the entire data pipeline, from raw input all the way to a live, scalable product.